Question number 5. For the following two circuits, calculate the unknown currents. The first thing you need to do is decide which way you want to walk around the circuit. So we can start here and we can walk this way, and we're going to call this one here loop A. Okay, and so for loop A, I'm going to generate an equation. So starting here, I walk with the current from the small side to the big side. So I'm going to gain from no volts to 15 volts. I'm going to gain 15 volts. I continue to walk down the circuit, come down here. Now this is I1, it's pointing that direction, so that means I1 must also be going that direction. So that's I1, which is heading through the 15 ohm resistor, and so I'm going to lose 15. The voltage is going to be here, it's going to be IR, so it's going to be I1, so 15 times I1. Okay, so the current times the resistance gives you the voltage lost across here. I come up from 0 volts up to 10, so I'm going to gain 10 volts through that power source. Now going again with the same direction as the current and the same direction as my loop. Okay, I'm going to lose 10 I3. Okay, that's the voltage lost. I3 times 10 or 10 I3, doesn't matter, and I'm back to where I started. So that's my whole loop, and Kirchhoff's voltage law says that if I go around a whole loop, the sum of voltage around any loop sums to 0. Now notice in here there's some like terms. I've got 15 and I've got 10 in here. Now probably the easiest way to solve these equations, I'm going to have 3 equations, so I've got 3 unknowns, is using a graphics calculator. And if you come over to the graphics calculator, you go to menu, you come down to equations. Now you see there's 3 different types of equation solvers, and if we go to a simultaneous equation, and there's going to be 3 unknowns, so we go to 3 unknowns. See, it's in the form ax, by, cz equals a number. Okay. Now the x in this case is going to be a1, current through current 1, I1. Next one's going to be I2, I3 equals a number. So what we want to do is we want to rearrange this equation so it can fit nicely into this. Okay, so we've got I1, so we're going to have minus 15 I1, and then is there any I2s? No, but we need to leave it in there, so it's 0 I2. Any I3s? Yep, there's 10 of them, minus 10 I3, and there's 15 and there's 10, so that makes 25 on this side, but our calculator over here says it's going to be on the other side, so that equals minus 25. Done. So there's our first equation, so we can type that into the calculator. Minus 15, 0, minus 10, and that equals negative 25. Okay. To generate the second equation, we need to again decide which way we want to walk around the circuit. Okay. It doesn't really matter which way you walk around. You'll end up getting a positive or negative, but the final answer will be the same. So we start down here at the red dot, from the small side to the big side, from 0 volts to 10. Okay. So the first part of our equation is going to be gaining 10 volts plus 10 volts. Okay, then I'm going in the same direction as my loop, going up, same direction as my current, so I'm going to lose 10 I3. Then now you notice that I'm walking this way, but my current's going that way, so I'm going to add the voltage lost. Okay, so it's going to be 12 I2, so it's going to be plus 12 I2, and again the same idea here, plus 8 I2. And again, the whole way around a circuit, because we go back down to the dot, Kirchhoff's voltage law says that the sum of the voltages around a circuit must sum to 0. Now, just like the first equation, we have some like terms, and again we want them in that same form, I1, I2, I3 equals number. Okay, is there any I1s in here? No, there's no I1s, but we still need that placeholder. So we go 0 I1. Is there any I2s? There's a 12 and there's an 8, so we've got like terms, so that means we've got 20 plus 20 I2. Any I3s? Yep, minus 10 I3. And that's going to equal 10 on this side, so it's going to equal negative 10. Okay, I can come over to my calculator for my second equation, and I've got 0 as the first number, I've got 20 as my second number, minus 10 as the third number, and that equals minus 10. Okay, so now we've done our two loops, and so you must ask, well, how do we get our third equation? The third equation is using Kirchhoff's current law. Current into a node equals current out of a node, so we can see I3 is going up, I2 is going across, and I1 is going out. So that means I2 I2 plus I3 must equal I1. Okay, so our third equation is going to be I1 equals I2 plus I3, and again we want it in the same equation, in the same form, so it's going to be I1 minus I2 minus I3 equals 0. Here we go, so we type this third equation to the calculator. Okay, so there's one I1, then there's a negative 1 I2, negative 1 I3, and that equals 0. Okay, so we have our three equations. We simply click solve, and there we go. So x is our I1, so our final answers end up being I1 equals 1 ampere, I2 doesn't actually exist, I2 equals 0 amperes, and I3 equals 1 ampere. Done.